In 1919, a 25-foot-high wave of dark, sticky liquid tore through the streets of Boston at 35 miles per hour. It crushed buildings, trapped horses, and killed 21 people. The killer wasn't water or oil. It was a substance most of us keep in our pantry for gingerbread cookies. We call it molasses. It is dark, mysterious, and smells like a mix of caramel and iron. But here is the truth. For centuries, the industry treated it as trash, a dirty byproduct of sugar production. What exactly is this liquid waste? Why was it the engine of the American Revolution? And how does it contain more minerals than the sugar it came from? Let's dive in, right here on What Exactly Is the Shadow of Sugar. To understand molasses, you have to understand the Great Extraction. It begins with sugarcane, a tropical grass packed with sweet juice. When that juice is boiled, the water evaporates, and pure sucrose crystals begin to form. These crystals are pulled out to become the white table sugar you know. What is left over, the thick, dark, unsugared syrup, is molasses. The 3 stages. Molasses is not just one thing. It's a journey. The first time you boil the juice, you get light molasses. It's the highest in sugar and the mildest in flavor. This is what you see on pancakes. Boil it a second time, and you get dark molasses. It's thicker, less sweet, and holds that signature gingerbread spice profile. This is where the complex chemistry starts to happen. But then, there is the third boil. This creates blackstrap molasses. This is the end of the road. Almost all the sugar is gone. What remains is a bitter, salty, mineral-dense sludge that is legally required in some countries to be labeled as a supplement. The chemistry. Why the bitterness? Why doesn't it taste like sugar? Because of a process called the Maillard reaction. As the juice is boiled repeatedly, the remaining sugars and amino acids react under high heat. This creates new flavor compounds, smoke, earth, and caramel. It also concentrates the minerals the plant sucked out of the ground: iron, calcium, and potassium. This is why molasses is a superfood byproduct, while white sugar is empty calories. The liquid engine of war. In the 1700s, molasses wasn't just for baking. It was the most important liquid in the world. Why? Because molasses plus yeast equals rum. The Caribbean produced the molasses. New England turned it into rum. It was an economic powerhouse. When the British tried to tax it with the Molasses Act, they didn't just hurt bakers. They fueled the fire that became the American Revolution. Sulfured versus unsulfured. When you go to the store, you'll see unsulfured on the label. This is a sign of quality. Sulfured molasses is made from young green cane and treated with sulfur dioxide to preserve it. It leaves a chemical off aftertaste. Unsulfured molasses comes from fully sun-ripened cane. It takes longer to make, but the flavor is pure, clean, and naturally preserved by its own high density. The forgotten disaster. Let's go back to that 1919 flood. Why was a molasses flood so much deadlier than a water flood? The answer is non-Newtonian physics. Molasses is incredibly viscous. When the giant tank in Boston burst, the syrup moved like a solid wall. As it cooled in the winter air, it became thicker, making it impossible for victims to swim out. It was like industrial quicksand. Even today, on hot summer days in Boston, some residents claim they can still smell the faint, sweet scent of molasses coming from the old docks. It is a permanent part of the city's DNA. Today, we have moved on to refined white sugars and corn syrups. We've traded depth for purity. But molasses remains. It is the ghost of the sugarcane plant. the part that refuses to be refined. It is proof that sometimes the leftovers are the most important part of the story. Thank you for joining us on this journey through the dark syrup of history. Hit subscribe button and stay curious.